Flipped classroom video for Maths AS Unit 1, Equations of Tangents and Normals. So we know how to find the gradient of the tangent to a curve, but sometimes we might want to know what the equation of a tangent to the curve is, and this is what this first bit's about. So first reminder is that one form of the general equation of a line is y minus y1 is mx minus x1, where x1, y1 is a point on the line and m is the gradient of the line. Reminder 2. The gradient of a curve at a point is defined as the gradient of the tangent to the curve at that point. Reminder 3. The gradient of the tangent is given by the value of dy by dx at the point we're looking at. Also, dy by dx can be written as f dashed of x. Conclusion. If we want to find the tangent to a curve at the point x1, y1, then it is y minus y1 is dy by dx times x minus x1, where dy by dx is calculated using the value x1. Another way we can write it is y minus y1 equals f dashed of x1 times x minus x1. So those are equivalent forms. Okay, so let's have a look at one. We have a curve y equals f of x, we have a point on that curve x1, y1, and the tangent there is going to be y minus y1 is mx minus x1, where m is either dy by dx calculated x1 or equivalently f dashed of x1. Let's have a look at an example. Find the equation of the tangent to the curve y equals x cubed minus 4x squared plus 7 at the point 2 minus 1. So, step 1, we need to find what the equation for dy by dx is, or the formula. X cubed, when we differentiate, becomes 3x squared, and minus 4x squared. Well, x squared differentiates to 2x, so that gives us minus 4 times 2x. So in the end, we have 3x squared minus 8x. Step 2, find the gradient at the point. Well, the x value is 2, so we need dy by dx when x is equal to 2. So we just substitute 2 in for the x in the formula for dy by dx, which gives us 3 times 2 squared minus 8 times 2. 3 times 2 squared is 12, 8 times 2 is 16, so that's 12 minus 16, so that gives us minus 4. Step 3, we use these values to find the equation of the tangent. So, we have y minus y1 is mx minus x1. Since y1 is minus 1, we have y take away minus 1. M is our gradient, and that is the dy by dx when x is 2 that we've just calculated, so that's our minus 4. Brackets x take away the x value of x1, which is 2. If we tidy up now, y take away minus 1 is the same as y plus 1, and then minus 4 times that bracket comes out as minus 4x plus 8. We can subtract 1 from both sides, which gives us y equals minus 4x plus 7. And we can have a look at a picture of that. So the red curve is our y equals x cubed minus 4x squared plus 7. The point 2 minus 1 is shown, and that is our tangent line, y equals minus 4x plus 7. And the minus 4x, we can see that makes sense, it's a negative gradient and it's quite steep. And the plus 7, that's the y-axis intercept. We can't see it on this diagram, but we can see that 7 is reasonable. And you can always have a try of this yourself on GeoGebra or Desmos, and you'll find that it all looks tickety-boo. So, the general equation of a normal to a curve. Well, what is a normal? We know what a tangent is. What's a normal to a curve? Well, definition. The normal to a curve at a point is the line through that point perpendicular to the tangent at that point. So, if we want to find a general equation for it, first reminder, the gradients of perpendicular lines multiply to -1. So that means the gradient of the normal line is given by -1 divided by the gradient of the tangent line. So that's -1 over dy by dx, calculated at the point, or equivalently we can write that as -1 over f dashed of x1. Our conclusion is that the normal to a curve at the point x1, y1 is going to be y minus y1 is mx minus x1, as usual. But this time m is -1 over dy by dx, or -1 over f dashed of x1, and note that dy by dx has to be calculated using the value x1. And we'll have a little look at a picture of that. We have the red curve, we have a tangent to the blue point, and the normal is going through that point but is at right angles to the tangent. So let's have a look at an example. Find the equation of the normal to the curve y equals x cubed minus 4x squared plus 7 at the point 2 minus 1. And that may look familiar to you. Step 1, find dy by dx. Well, we worked that out before, but we've got 3x squared. The x squared differentiates to 2x, so that's -4 times that 2x, which gives us 3x squared minus 8x. Find the gradient at that point. So we put the value 2 in, which gives us -4, as before. Step 3, find the gradient of the normal to the curve. Well, the gradient of the normal, which I've called mn, is -1 over the gradient of the tangent. So in this case, it's -1 over -4, which is 1/4. Use these values to find the equation of the normal. So we can just pop them in. Y minus y1 is mx minus x1. x1 and y1 come from the point. The gradient m is our quarter. And that means y take away -1, so that gives us y plus 1. When we open the bracket up, we get 1/4 times x, and we get 1/4 times -2, which is -1/2. And then we can subtract 1 from both sides, and we end up with y equals 1/4 x minus 3 over 2. And we might choose to write that as 4y equals x minus 6. It's a tidier way of writing it. But either way, there's a picture of it. We have our y equals x cubed minus 4x squared plus 7 from before, and our fairly steep tangent going up, and then you can see the normal line coming across at right angles to it.